And speaking of problems that we love to work out, we got problem of the day waiting for you. Let's take a look at it. It says, if a fair coin, that means heads and tails is equally likely, is flipped 3 times, what is the probability of having 3 heads or 3 tails appear? All right, so again, we're going to flip that coin 3 times, and we're going to get heads or tails on each of those tosses, and we want to know what's the probability of having 3 heads or 3 tails appear. So let's take a look at it here. If we were going to win money, all right, what's your chance of winning big money? I don't know what you're paying to play the game, but it's just like a little game, it is. And what kind of payback do you get for getting, as you say, 3 heads or 3 tails? And you might just get a pat on the back, you know, who knows? But let's see what happens on this. Storyline. I like to do tree diagrams when we have a probability problem. Boy, probability problem. Now you can say that a lot of times, it'll get kind of weird, doesn't it? And on our first toss, I want to point out to you, this is going to be our first flip, okay? First toss. We have 2 options. We could go heads or tails. You say, well, Ernie, what do you mean by tree diagram? Well, these are like little branches. Somewhere out there, there's a trunk, all right? And we're going to continue these branches on out here. Well, we're going to have a second toss. Now, friends, if you got heads on the first, what's your chance for heads on the second? Oh, it's the same story, isn't it? You can have heads or tails, all right? Then we got a third toss that we're going to make. Oh, wait a minute. Some of you are saying, Ernie, what about if they get tails? Same story, isn't it? Because it's still heads, tails, and it's still a 50-50 chance. We'll put some probabilities on these tree branches here in just a second so you see where it's going. All right? Aha! So there's our second trial. Let's do a third. Oh my goodness, we are just into the mess here. Let me just really take that one out far here. We're going to go, this is going to be our third toss, and we're going to have heads or tails. That's the strangest looking H, isn't it? And we're going to do the same thing here. We'll pull it out H or T. Give it a little bit of room. Another heads or tails going here. And last but not least, one more going here. Heads or tails. Now, notice something here. It doesn't matter. And you say, well, Ernie, what in the world are all those things about? You didn't toss it 4 times? No. But these are the possibilities. First of all, if I hit heads on the first one, I could go, watch this. That's an H again. Those of you are saying, what is that? This looks worse than ever, doesn't it? Let's put an H right there. Now we know what it is. What happens here, if we'll follow the tree, that's one of our options. There's a heads, heads, and heads. So there's 3 heads right there. You say, this sounds like something we were looking for. It does, doesn't it? It's problem over? Well, we got to figure out how many outcomes we got here. This one is heads. Oh, follow the trip. Heads, heads, tails. See where I went? Went back up to the second toss. So on the first toss, you get a head. The second toss, you've got heads or tails, all right? Then the third toss, again, you could hit heads or tails. So you start seeing how this is going to work. So we had 3 heads on this limb. We have heads, heads, and tails there, all right? So that is flowing through here. Skip that little H that got up into almost into the block there. Now, this set is going to come out here and equal. We'll follow the lines here, follow the H's and T's. This time it went heads, but we got a tail on the second toss. And then guess what? We could get a head or a tail on the third. So we put heads, tails, heads, and we'll just find this one right on down there. That will be heads, tails, and tails. So far we've got 4 options. Now you're saying, how do we know what the probabilities are, Ernie? Well, let's put a little probability on this first one. We knew it was 50-50, 1/2, 1/2. We flip that coin. We do it again. My goodness, folks, it's still the same fair coin. So it's going to be what? 1/2 and 1/2, right? Everybody follow? So if I hit heads, I flip again. But you know what? If I hit tails, I flip again. And it's still the same story. So this is our second toss. This happens if I get heads from the first one, I toss again. But if I get tails on the first one, I toss again also. It's still 1/2 and 1/2. You say, well, what are you going to do with those halves? Hang on, all right? Be patient. Now, we flip again. Let's stay down here in the tails for just a minute because we've already kind of played out these guys up here. See what happened? So we've gone 2 tosses. Let's get to the third one going here. How about it? Let's take tails, heads, and heads. Now, why is the tree diagram so great? It shows you all the possible outcomes. You might not need them all. And in reality, we probably don't necessarily hear, but we need to know how many we've got. And the tree diagram definitely will tell us. It'll also tell you the order things happen. And each of these orders is going to have a little subtle difference. So let's keep a looking here. I've got tails, heads, tails. Isn't that sweet? THT. Let's play out another round here. This is going to give us tails, tails, heads. If I can put the right letters down, you will have, looks like 8 different pieces here. And then we got tails, tails, tails. Now my question is, what about this branch? You know what? It's still 50-50, isn't it? It's still 1/2 chance for heads, a 1/2 chance for tails. It's one or the other. We don't have a, well, maybe, all right? It's either heads or it's tails when we flip that coin. So there's 1/2 and 1/2 again. Oh my goodness, 1/2, 1/2 again. I'll put it right in there because it's getting a little tight. How about it 1/2 here, 1/2 there? And look what happens. We're going to multiply. Yes, we're going to multiply. 1/2 times 1/2 times 1/2, which is going to give us 1/8. These are what we call independent events because the probabilities don't change as the game plays on. It's still 1/2 each time. So it's an independent set of events. By the way, this one's going to be a 1/2, and this little guy's going to be a 1/2 here. So we're going to get 1/8 up here, 1/8. Let's see if I can do that right. Again, 1 out of 8, 1/8, 1/8, 1/8, because all these branches are 1/2 times 1/2 times 1/2. So we get 1/8, 1/8, 1/8. The question asks, what's the probability of having 3 heads or 3 tails? That's what we're interested in. Now, I'm sorry I gave you a long, drawn-out road here, but here is where I have a success. Each of those are 1/8 a chance. So you say, well, which one are we talking about, Ernie? It says or. That means I want to know what's the chance of me getting 3 heads or 3 tails. I win. I win with either of those combinations. One is not better than the other. They're equally likely. They're equally worth the same. That means I have 2/8 of a chance. We'll add those, 1/8 plus 1/8. And you know what we get? 2/8, which equals 1 chance in 4. So if I'm playing this game, flip a coin 3 times, and I have a chance to have either all heads or all tails, I'm going to win probably about 25% of the time, give or take. Obviously, it's not going to be perfect because we have odd numbers at times, so how do you do that? But if we play it long enough and to the long run, we'll get close to 25% of the time, 4th winning there. So there you go, a little probability there, maybe more than some of you wanted, but tree diagram, and then also read and read and read it right.